In this video, I'll be sharing with you 5 steps that you can follow to become a software engineer. Now, these are in the order in which you should follow them in, but I just want to mention that this is not going to be an exhaustive list. It's not going to work for everybody. This is just my opinion on what you should probably learn and the order in which you should learn it if you want to become a software engineer as quickly as possible. So with that said, let me list out what these different topics are, and then I'll elaborate on them as we go through the video. So step number 1 is going to be to master the basics. Step 2 is to write clean and efficient code. Step 3 is to learn software engineering tools. Step 4 is to get into advanced programming. And step 5 is to learn about software design and architecture. Now, again, this is not going to be a complete list for everyone. If you're going into a specific field of software engineering, say like web development, then you're definitely going to need to learn other things. However, I think this is a really good general outline and should apply to most people trying to become a software engineer. Now, with that said, if you want to learn this content as quickly as possible, you of course can follow YouTube channels like mine. Find great free resources online, that's definitely doable, but to learn this as quickly as possible, you should check out programmingexpert.io. Now, Programming Expert is a course that I just released with the Algo Expert team that is literally designed to make you a software engineer as quickly as possible. You can check it out from the link in the description, programmingexpert.io, and use the discount code TIM at checkout if you want a discount. I'll let you guys look at that, but it's literally designed to make you a software engineer and covers almost everything that I already mentioned in this video. All right, so let's go ahead and get started. Step number 1 is master the basics. And what I think you should do in this step is get good at least one programming language and understand programming fundamentals and really build a strong foundation for yourself so you are comfortable and confident writing code. I think this is the most important step for really anyone trying to become a software engineer, is to get a really solid foundation and understand the core concepts that are going to apply throughout every single language, every single framework, and pretty much everything you do going forward. So just give you a few examples here. I think that you should understand data types, variables, conditions, looping, functions, object-oriented programming. All of these topics that are going to apply again to pretty much everything. Now, the reason I'm really emphasizing this is because a lot of people will immediately dive into something like a front-end framework or machine learning or game development or all of these other very interesting topics. Now, I'm not trying to say that you can't do that as a beginner. You can, but it's way easier and less discouraging when you already have a solid foundation underneath you. Imagine going and trying to learn 3D game development without knowing how to write a single line of code. Well, now you're doubling the amount of work you have to do to feel successful or accomplished in this field, because now you have to learn 3D game development as well as whatever the programming language is that's being used to do that. You don't have the foundation, and so the amount of stuff you have to do to actually achieve something, maybe build a project, is a lot more. Whereas if you build the strong foundation first, this is a really great step, builds some confidence, and allows you to feel more comfortable actually writing code, solving problems, and then moving on to any other frameworks, modules, or specific things that you want to learn. Hopefully that makes sense, but that is step number 1, master the basics. All right, so now we are moving on to step number 2, which is to write clean and efficient code. Now, I understand this might be a little bit controversial because some people will only really do this once they've gone through almost all the other steps that I've listed. However, I think it's very important to build strong habits when you're starting out with programming and to learn how to properly write code and write code in a clean and efficient manner. Now, to do that, you need to learn things like time complexity and space complexity, essentially analyzing code and understanding which code is more efficient than others. Now, this is not extremely difficult to do, especially if you're doing it on a very surface level and not getting into any super advanced data structures and algorithms. But I think having that understanding and realizing, hey, I probably shouldn't have 3 nested for loops inside of each other unless I absolutely need to have that. Or, oh, this approach is a better way to solve this problem. It's going to be more efficient. It's going to use less space. Or on the other way, maybe I'm going to write something that's a little less efficient, but is going to be way easier to understand. And I'm going to be able to go back to this in a few months and be able to modify it, tweak it, whatever. That's kind of what I'm talking about in this section, is building strong habits and writing code in a way that's maintainable and sustainable. Now, just to add one last point here from personal experience, I was someone that was learning to code when I was a lot younger. I was about 11, 12 years old. And so most of the code that I wrote back then never needed to be seen by anyone else. It was just for myself. So I didn't care how it looked. I didn't care how maintainable it was. I didn't care about consistency, naming conventions, all of those types of things. And I built a really bad habit of just writing honestly horrible code that worked, that solved the problem, but that was really hard to maintain, hard to read, and hard to understand. And so as I was getting older, I had to actively work on changing the way that I wrote code, because now I was getting into the industry, actually working in a job and presenting my code to other people and in YouTube videos. So that's why I'm putting this step right here. It's not very difficult to do, but learning things like how to write self-documenting code, avoiding repetition, structuring your code in a very easy way to understand, really, really important and a good habit to build early on. All right, so now we're moving on to step number 3, which is to learn software engineering tools. So at this point in time, you should be comfortable writing code. You should have some confidence in writing code as well. Hopefully you've solved some small problems. You've worked on some projects. You understand how to structure your code and write clean code. You kind of have the basic skills down. Now to get to the next level, I think it's important to learn the software engineering tools that you'll use in a professional environment, right? So for example, some of the tools you may want to learn would be Git and GitHub. This allows you to work with multiple people on the same code base, allows you to store previous versions of your code base. I have all kinds of tutorials on it on this channel. It's also on Programming Expert. I also would recommend learning something like Bash. Now, Bash is a command line tool. This is going to be used on Mac or Linux, and this is kind of in replacement of your graphical user interface. So a lot of times when you're working as a programmer or as a software engineer, you're not going to have access to a nice graphical user interface and desktop and all of that stuff. You're going to have to do everything right from the command line. And I think it's important to have a basic understanding of the command line tools, how to navigate a Linux operating system. These are things that you might not have to do, but that I think are pretty important and that are a good skill to have as a programmer. For example, understand how to run your code directly from the command line without using the little run button in your editor, right? That's something that I think most software engineers should know how to do. And again, how to create files, navigate the file system, all that type of stuff. Continuing, I also think that you should learn about IDEs. Now, an IDE is an integrated development environment. At this point, you've probably already worked in one if you've gone through these steps. However, I think it's important to have a proficiency with your IDE, understand the different keyboard shortcuts, how to use things like debuggers, and a lot of the professional tools that IDEs will offer to you. For example, VS Code is an IDE. That's one that I would recommend if anyone is looking for one to learn. Continuing, I think you should learn about basic networking. Now, this is something you might be able to omit from this list, but understanding things like HTTP, IP addresses, just the basics on what networking is, how networking actually works on a very, very surface level, I think is nice to know as a software engineer, because a lot of times you're using features in your code that rely on networking, and to just have that basic understanding just makes everything easier to do. All right, so that is going to wrap up this section. Again, I have for you Git, Bash, IDEs, and networking. There's a ton of other tools you could potentially learn here, and those are probably going to differ depending on the specific discipline of software engineering that you're getting into. All right, so step number 4 is to get into advanced programming. Now, advanced programming could have so many different topics within it. This, of course, is very vague, but I think you should step outside of your comfort zone now and start learning about more advanced features and things that you don't necessarily need to use, but that you will probably see and should understand how they work. So I'm just going to name a bunch of topics off the top of my head. Again, non-exhaustive list, just some things that I'm thinking of right now. So probably threading, multiprocessing, asynchronous programming, iterators, generators, compilers, interpreters, how your code is actually ran and executed, maybe things like decorators, standard libraries, all of these different topics that are fairly advanced that you probably want to at least have a basic understanding of and know what they look like in whatever programming language you're working. Now, if you're working in a professional environment, unless you're a senior programmer, you're probably not going to have to implement a multi-processed application. You might, but that's unlikely. But a lot of times you'll see in the code base that you're working in, there'll be a bunch of advanced features that are used, and you'll have to understand how they work. So this is really more about just being able to read this type of code than it is about writing this type of code. And that's kind of why I threw this section in here, because I think it's important to know these different topics, even if you don't know how to implement them yourself. All right, so that is what I have for advanced programming. Again, I apologize that this is vague. It's really going to depend on the type of software engineer that you're trying to be, but those are the few things that I can think of off the top of my head. All right, so now we're moving on to the last step, which is software design and software architecture. Now, this is something that's very difficult and that most of us are really never going to have to do, at least on a super impactful level. But the reason I'm including it here is because as a software engineer, I think it's important to understand things like design patterns, good coding practices, the different approaches you can use when designing specific applications and pieces of software. Even something simple like picking your tech stack, right? Those are things that actually differentiate, in my opinion, programmers and kind of people that write scripts from people who are software engineers. I think it's pretty easy to actually get into programming and learn how to write basic code or, create basic projects, but to be able to work on large scale applications, design entire websites, design things like Netflix, Facebook, Google, things that need to scale to millions of people, that is what software engineers do. And when you get to a super senior level of software engineering, which full disclosure, I am nowhere near, that's when you start to really get good at this stuff and when that's your main responsibility. Now, to give you some concrete examples here, or I guess a personal experience, I interned at Microsoft about a year and a half ago. And when I was there, the number one thing that I saw that separated people like me from people that were super senior software engineers was their ability to do software design and software architecture. To look at something from a very large macro perspective and say, what approach are we going to go with here? What are the advantages? What are the drawbacks? Is this maybe the better approach because it's going to be faster to implement? All of that type of stuff. Even just to design a system in terms of laying out the different components, structuring a code base, picking the tech stack, right? All of that type of stuff was what those guys were very, very good at doing and what our team relied on them to do so that someone like me could go in and implement the individual features. And just as a last note here, I think that after you get good at software design and software architecture, you're probably at a level where you're comfortable to design any type of system, any type of application. And what comes next is really up to you. Do you want to master a specific framework, master a specific language? Do you want to get into machine learning and AI? Do you want to do front-end web development? Whatever it may be, I think once you get to this point in your software engineering career, it's really about what you want to learn next. You should have the skills and confidence to learn it, and well, then you go, learn it, get good at that, and continue from there. So with that said, I think I'm going to wrap up the video here. As a reminder, almost all of the topics in this video are covered on programmingexpert.io. Check it out from the link in the description. Use code TIM for a discount. If you guys enjoyed, make sure to leave a like, subscribe to the channel, and I will see you in another one.